Okay, guys. Sorry this is going out so late. I had a really busy night. So you already saw this yesterday. I'm just gonna get my pen light going.
Pen light?
He can talk. It doesn't matter. That was my kid. He's asking what pen light is. Come here and I'll show you.
Alright.
See the circle around my cursor?
Yeah.
So when I can say this right here so the kids can see it from far away. Ladies and gentlemen, my boy, Sinjin.
Thank you.
He'll be appearing here until he turns 18 and I kick him out. Alright, so let's do this. I have a vertex. Since I have a vertex, I can go in vertex form, which is y equals a x minus p squared plus q. So I've got a y and an x. And what do I have here? A y, an x, and a y. So all I got to do is take this over to here, and there is a p and a q. And I just take this over to here. So I end up with negative 15 equals a 0 minus 6 squared plus 3. Solve that. Negative 15 equals 36a plus 3 minus 3 minus 3. Negative 18 equals 36a. A equals negative 1/2. And that makes good sense because, as you can see, this is turned over upside down. So the equation that I am dealing with in vertex form is y equals negative 1/2 x minus 6 squared plus 3. But I don't want vertex form. I want standard form. So all I got to do is expand this. So y equals negative 1/2 x squared minus 12x plus 36 plus 3, which is y equals negative 1/2 x squared plus 6x minus 18 plus 3, which is y equals negative 1/2 x squared plus 6x minus 15. And now I check. It's got the right y-intercept. It's got the right stretch factor. So we're in good shape. Now, the one that was killing everybody, apparently. This one. I need to figure this out, but I have 3 points. Notice that none of those points are a vertex. So I'm going to slide over this way, and I'm going to do something a little crazy. I know that I need ax squared plus bx plus c equals 0, right? And I know that not 0, sorry guys, equals y. Now, that is this parabola's equation. That parabola has x's and y's. Here, I have x's and y's. Now watch what I'm going to do. This one I'm going to write in black. There's an x, there's a y. There's an x, there's a y. So I'm going to get negative 2 squared a plus negative 2b plus c equals 9, my y. Work that out. 4a minus 2b plus c equals 9. That is equation 1. Here's a second point. There's an x, there's a y. Let's do this. 2 squared a plus 2b plus c equals negative 7. Fix that up. 4a plus 2b plus c equals negative 7. There is equation 2. My third equation, right here, xy, 4 squared a plus 4b, because b, 4 and x, plus c equals 3. Sort that out. 16a plus 4b plus c equals 3. There is equation 3. Now, watch this. This is something you learned in grade 10. 4a minus 2b plus c equals 9. 4a plus 2b plus c equals negative 7. And 16a plus 4b plus c equals 3. Hopefully you remember systems of equations from the 10th grade. And here's how this works. Eliminate some of these equations. The easiest way to do that is to, with these two, you could do some elimination there. Or you could change them around to eliminate variables. Or you can do substitution, which for this is what I like better. Take this equation here. C equals 9 minus 4a plus 2b. Right? Now, if that's what C is, there's a C and there's a C. So watch what happens. 4a plus 2b plus 9 minus 4a plus 2b, because that's what C is, equals negative 7. What happens there? 4a's go away. 2b and 2b is 4b plus 9 equals negative 7. 4b equals negative 16. b equals negative 4. Now I've got a b and a c. There's my b. There's a b. So I can go to this third one and go 16a plus 4 times negative 4, because that's what b is, plus 9 minus 4a plus 2b, oops, not 2b, plus 2 times negative 4 equals 3. Do my math. 16a minus 16 plus 9 minus 4a minus 8 equals 3. 12a minus 24 plus 9, so minus 15 equals 3. 12a equals 18, and a equals 3 halves. So now I have a and b. I don't know c, but I know a and b. C equals 9 minus 4 times 3 halves, which is 12 over 2, plus 2 times negative 4. C equals 9 minus 6 minus 8, which equals 9 minus 6 is 3, 3 minus 8 is negative 5. So now I have C, C, B, B, and A. So all I got to do is rewrite the equation. A is 3 halves, so y equals A 3 halves x squared plus b is negative 4. So it's plus negative 4. So I'm going to do minus 4x. And c is negative 5, minus 5. And there we go. Not too difficult if you remember systems. If you don't, pretty darned impossible. I have the vertex here, so this one's an easy one. Y equals a x minus 2 squared plus 1, 0 and 5. 5 equals a 0 minus 2 squared plus 1. 5 equals 4a plus 1. 4 equals 4a. A equals 1. So I don't need to write it. So this one is y equals x minus 2 squared plus 1. Done. This one. Okay, I have my roots, right? So my vertex x has to be halfway between those, which is 6 plus 2 over 2, which means my vertex x has to be 4. Sorry, not 6 plus 2, 6 plus negative 2, which is 4 over 2, which is 2. So my vertex x is 2. So now, since I know my vertex x, y equals, oops, forgot the a, y equals a x minus 2 squared plus q. I know my y and my x, but I don't know my a. So this doesn't really work, does it? But I do know that y also equals a x minus 6 and x plus 2, don't I? And now I can work it out because I got all kinds of points that can go in for x. Negative 12 equals a 0 minus 6, which is negative 6, and 0 plus 2, which is 2. So negative 12 equals negative 12a. So a equals 1. So again, I've got it set. Since a is 1, this is y equals x minus 6, x plus 2. Done. Here I have a vertex. So once I have a vertex, I'm in business. Y equals a x plus 1 squared plus 8. 5 equals a 0 plus 1 squared plus 8. 1 squared is 1, so 5 equals a plus 8 minus 8 minus 8. Negative 3 equals a. So now I fill it in. Y equals negative 3 x plus 1 squared plus 8. Now let's check and make sure. If it's negative 3 for a stretch, when I go over 1, I'm supposed to go down how far? 1, but I went down 3, so it's right. Got my roots. Y equals a x plus 1, x minus 6. And there's my y and my x point right there. So negative 5 equals a 4 plus 1 times 4 minus 6. Negative 5 equals 4 plus 1 is 5. 4 minus 6 is negative 2. 5 times negative 2 is negative 10. Negative 10a. A equals 1/2. Y equals 1/2. A x plus 1, x minus 6. I just got to check something, guys. I can't remember. Did I ask for these in general form? Oh, in standard form I did. Curses. Well, I'm too lazy to go back and fix everything I did, so I'm going to leave them like this. To standard form them, of course, you just expand it. This is another systems one. I don't have a lot of room, so I'm not going to go through that one. Maybe I will... if I can find some room, I will. I'll come back to that one, but I just did one like that. This one here, this one's a little weird because I don't technically have a vertex, do I? But I have my two roots, 0, 0, and 20, 0. So y equals a x minus 0 and x minus 20. So y really equals ax, because a times x, sorry, a y equals a x squared, right, minus 20x minus 0x minus 0. So x squared minus 20x equals y. And I can plug in any of my equations. But that's weird because I got the two of them here. Let's just see what happens. 30 equals a 5 squared minus 20 times 5. 30 equals a 25 minus 100. 30 equals negative 75a. A equals negative 30 over 75, which is negative 2/5 equals a. So now I've got right here y equals negative 2/5 x squared minus 20x. And then of course I would expand it. Here I've got my vertex, so I'm on easy street. Y equals a x minus 2 squared plus 25. Go ahead and fill it in. Doesn't matter what other point you use. 0 equals a 7 minus 2 squared plus 25. 0 equals 25a plus 25. Negative 25 equals 25a. A equals negative 1. Y equals negative x minus 2 squared plus 25. Expand it, collect your like terms. You're in standard form. And finally, number 8, I have my vertex. So again, y equals a x minus 1/2 squared plus 0. Ooh, that's weird. Okay, so I don't need that. 3 equals a 1 minus 1/2 squared. 3 equals 1 minus 1/2 is a half. A half squared is a quarter. So 1/4 a, which is 3 equals a over 4. So 12 equals a. So now I go to here, and I go y equals 12 x minus 1/2 squared. Now, that looks weird, so I want to check that. That means if I go over 1, I should go up 12, yes? So here, 0.5 over to 1, I'm going over 1, but I'm going up 3. Is that right? I'm supposed to go over 1 and up 12, right? If I go over 1, I go up 12. I'm not going over 1, I'm going over a half. So how does that work? If I go over 1 and I go up 12, but I go over a half and I go up 3, that's a quarter, right? of 12. So it works. Sorry, I got an itchy leg. And then, of course, you would expand it and you'd be in standard form. I didn't expand them because you guys don't need that really. You can do that. This I'll do again tomorrow on a big screen because I'm out of space.